Lesson 15, section 6.5, we're looking at inverse trig functions here. Now, there's something very important about this that I hope you guys recall from pre-calc section 1. And you'll notice that this has the definition of inverse, okay, and the notation of inverse, and what it definitely doesn't mean for us to have f to the power of -1. Again, this is the function f to the power of -1, not a variable, okay. This is specifically referring to the inverse function. So, how can we visually determine if a function is the inverse of another? Again, visually, looking at the graph. Okay, looking at the graph. I will answer this question here shortly. And then question number 5 is how can you algebraically determine if a function is inverse of another? Now, in both of those circumstances, okay, visually, I hope you were thinking for visually, the inverse of a graph is the graph of the equation reflected over this line, this y equals x line. Okay, so remembering that in my situation, in my problem, I can replace x and y. Okay, again, if I wanted to prove, replace x and y with y and vice versa, and I can solve for the new y. That will give me my inverse equation. Okay. Now, if I draw two different equations on here, I hope you recognize what they are. This one right here. Okay. This one is y equals e to the x, the exponential equation. Where is its inverse? Well, it sits right about here. Okay. And everything that you see about this thing, if I were to fold along this line, again, fold along this line, they would look exactly matching up. This is y equals the natural log of x. Okay. So, the question now is, okay, I'm going to move over here. If I gave you y equals to the sine of x, okay, or should I say f of x is equal to, what is f inverse of x equal to? Okay, that would be the question. Well, you would simply tell me that the inverse is sine inverse of x. Okay, and again, remembering that this negative power here is not a power. It's the notation for inverse, okay? Now, when is this actually equal to y? Right here. When I swap x and y equals to x, and I get sine inverse, okay, of that, and I solve. Now, how do I solve and get y by itself in this situation? Well, how do I eliminate the inverse function? How do I eliminate the inverse function? Well, I have a quadratic, and its inverse is the square root. X squared equals to y. How do I eliminate that square root? Sorry, the radical. I square root both sides. If I gave you y equals e to the x, how do I eliminate the exponential? I take the natural log of both sides. If I gave you, I don't know, let's just say I had a 1 over x equation. How would I eliminate the 1 over x piece? I would multiply, instead of divide, both sides by x. So, in this case, what I'm going to do here, I am simply going to take the sine of both sides. And what should happen with the sine of sine inverse? The sine of sine inverse of y? It should cancel out. And again, give me that appropriate information. If this is f of x, okay, then f inverse should be sine inverse of x. Okay, we do not have any other nice notation for this. This is simply the notation we're going to use. Okay, now the biggest piece that's a problem with this is, when is this supposed to happen? Well, let's talk about the inverse and when they occur. This right here is my sine function, and yes, it does continue on forever. Now let's see if we can recall back to pre-calc 163, the first semester. You'll remember that for us to have an inverse, it must pass the horizontal line test. Because what am I going to do with this? I'm going to flip it. Okay, I'm going to flip it over that y equals x line, and it's going to actually do something like this. If I can do this correctly, it would go like this, so now it's going to go like this. So it's going to go like this in both directions. Okay. how does this become an inverse function when it does not pass the vertical line test? Again, that's why it has to pass the horizontal line test here. So what we try and do is we try and pick a set of values. We try and pick a set of values that wherever I draw my line, it will always pass that vertical line test. Okay? Very carefully, I'm going to pick this set of values between those 2 points. Okay? What is that set of values? It's negative pi over 2 to pi over 2. Now, why would I select that set of values? Well, try selecting any other set. Okay, and let me actually switch to a different color here so you can see this. Let me try going from here to here. What happens if I ignore all the other values? I still don't pass the vertical line test. If I try and pick the values down here, again, between here and here, I don't pass the vertical line test. The only set of values that will work efficiently will be from this dark line right here, negative pi over 2, to that dark line up there. Okay, negative pi over 2, or sorry, pi over 2. Okay, so you'll notice now why we have defined this the way we have. The inverse function, okay, is the inverse function if and only if this is true, okay, and my domain on this function right here, the values I can plug in for x, are between negative 1 and 1. Well, why? Because the values for x in this inverse function are from here to here. Again, from here to here. And that used to be the values in y up here. What were those values? Negative 1 to 1. Okay, again, negative 1 to 1. And then you'll notice the y values that I can get back are between negative pi over 2 and pi over 2. Well, I go up to pi over 2, and I can go down to negative pi over 2. Okay, so you'll notice that the inverse sine function actually starts here and goes to here. X values being from 1 to a negative 1, y values being from pi over 2 to a negative pi over 2. Okay, these are the only values that I can get back or plug into the sine inverse function. Okay, keep that in mind. Likewise, for the cosine function, let me go ahead and draw the picture of the cosine function. That starts up high, low, back to high, and it comes down this way appropriately. Okay, so if I were to flip this one now, flipping this one would take this point and it would actually move it to where? Well, this is going to be the point technically 0, 1, so now it's going to be 1, 0, so it's going to be somewhere over here. Okay, and it's going to come down and then it's going to circle back around. Okay, it's going to do the same thing on the other side. So the question would be, what set of values on this line would allow me to pass the vertical line test? Well, if I try and pick any of these two sets of values, that will break. So I know I can't select the set of values down here with this set of values right here. So let me just start here. Okay, and this is okay, this is okay, this is okay, this is okay. It's okay up till about here. Once I start picking above it, I'm not passing the vertical line test anymore. So, what set of values is that? That's between 0 and pi. And you'll notice the x values that I can pick are between 1 and negative 1 again. Okay, which logically corresponds to what we have on this definition. Okay, so again, notice the only values that I can plug into the inverse function for sine and cosine are negative 1 to 1. The only values that I will get back for sine are between negative pi over 2 and pi over 2. We define it this way so that it's a consistent, continuous function. Again, I'm going to zoom out for that piece. We are going to define it this way so it is a continuous, consistent function. Okay, we're not defining it any other way. You'll notice that the cosine function will look very similar. However, it will start here and we'll circle around to about here. Okay, and this is again the x values of 1 to negative 1 and the y values from 0 to pi. Okay? This is how it's defined. We will utilize this information in terms of the inverse trig functions, again in terms of the inverse trig functions from this point forward.